Imagine it's a beautiful day at the beach and you decide, I'm gonna build the best sandcastle there's ever been. So you start building and suddenly a wave comes crashing in, washing everything away. You think, I thought I was far enough away from the ocean. How did that happen? So you go further away from the water and think, my sandcastle is gonna be safe now. Then a few minutes later, it's washed away again by the water. You're confused, thinking, does the ocean just hate my sandcastles? While it may be annoying, the ocean does not hate your sandcastle. This movement of the water creeping up the beach is actually an incredible part of our Earth. I'll let you in on a little secret. The moon and the sun are actually pulling the ocean. So if anyone hates your sandcastle, it's the moon and the sun. So you may be thinking, there's no way. That sounds like magic. The moon and the sun are so far away. There's literally no way. You're lying. I'm actually not lying. Let me explain. What you're experiencing is called tides. So first, there are low tides, where the ocean is pulled back, exposing a lot of the beach. Then there are high tides, which destroyed your sandcastle earlier. Well, that's cool and all, but what do the moon and the sun have to do with anything? The key is gravity. When I throw an object into the air, let's say my pencil, what does it do? It comes back down. What makes my pencil come back down is an invisible force called gravity. Gravity not only affects people and objects on Earth, but it also affects planets and moons, including our own. Gravity makes objects attracted to one another. The moon is attracted to the Earth, and the Earth is attracted to the moon, all because of gravity. Part of the Earth that is facing the moon experiences a gravitational attraction of the moon. The pull of gravity towards the moon increases sea level, causing a high tide. On the other side of the Earth, which is facing away from the moon, the rotational force of the Earth is stronger than the moon's gravitational pull. The rotational force causes water to pile up as the water tries to resist that force. So, high tides form on this side too. However, this high tide is not as high as the one on the side facing the Earth. The places that are in between the high tides, where the water is being pulled away, are where the low tides occur. But I thought you said something about the sun. The sun does affect tides. However, since the sun is so much further away from the moon, the gravitational pull of the moon is so much stronger than the sun. Fun fact, the sun is about 93 million miles away from Earth, while the moon is only 238,000 miles away from the Earth. The combined gravitational force of the moon and the sun is the reasons we have tides on this Earth. But why do beaches have low and high tides then? You have to remember, the Earth is always spinning. The gravitational pull of the moon and the sun creates a sort of bulge. And inside that bulge, the Earth is always spinning. This is why beaches experience times of high tide and times of low tide. Because if you take, for example, Myrtle Beach, South Carolina, which is on, the coast of South Carolina, it is always spinning because the Earth is always spinning. So when the Earth is spinning inside that bulge, it's going through points of the high tides and the low tides as it spins. But isn't the moon always rotating around the Earth? And aren't we rotating around the sun? Shouldn't that affect tides too? Yes, it does. The position of the moon and the sun determine whether the tides are considered what we call spring tides or what we call neap tides. Spring tides occur during a full moon or a new moon, when the Earth, moon, and sun are all in a line. This combines the force of the moon and sun together, creating the highest high tides and the lowest low tides. Neap tides occur during the first quarter and third quarter moon. This happens when the moon is perpendicular to the sun, which means it sort of makes like an L shape. Because the sun and the moon's gravitational forces are not combined, this makes the lowest high tides and the highest low tides. Since spring tides have the highest high tides, which means the ocean is really, really far off the beach, and the lowest low tides, which means the ocean is super far out, exposing a lot of the beach, spring tides would have the highest tidal range. But what do you mean by tidal range? The tidal range is the height difference between the high and the low tides. So to calculate tidal range, you would basically take how far up the beach the high tides go and subtract it by how far up the low tides go. And that would be your tidal range. So neap tides would have the smallest tidal range. Since neap tides have the lowest high tides, which is where the ocean does go further up the beach, but not as high as it would with spring tides, and the highest low tides, the ocean recedes back, but again, it's not as far as it would be with spring tides. The difference between the high tide height and the low tide height would be smaller. Places where large tidal ranges are regular, a tidal bore can occur. When the incoming tide is funneled into a shallow river, the tide actually flows up the river, going against the direction of the river's current. So just imagine, we have a river. And the river is going towards me, let's say. The tide would actually, because the tide is so strong, it would actually come in and make the water go against its actual current. And this is what's called as a tidal bore. And some people even surf the tidal wave that forms. But this is very dangerous. Bay of Fundy in New Brunswick, Canada, has the highest tidal range in the world. The height difference between the high and low tide is actually 56 feet. To show you just how extreme these tides are, here's a time lapse of one day. Tides seem super cool and all, but are they even important? On the southern US coast, the high tide floods rivers and marshlands with more than a foot of water. Crabs and fish use this as an opportunity to feed on smaller fish and water creatures that live in the marshlands. At low tide, oyster rocks and tide pools are exposed, also allowing crabs to feed. Another example would be raccoons. Crazily enough, as you can see, these raccoons from Vancouver Island, for example, actually use low spring tides to go further down the beach to feed on crabs that are burrowed in the sand. It's not only marine life. People use tides too. And it's not just to determine when's the best time to build your sandcastle, but sure. A lot of fishermen can even use whether tides are going to be high or low to determine whether it's a good time to go fishing. And people gotta eat. A lot of people like fish. We eat a lot of fish. Earth just would not be the same without tides, and so many creatures, including ourselves, would suffer if we did not have tides on this earth. Earth would just not be the same without tides. That's why they're so cool, and that's why they're so important. So the next time you are building a sandcastle on the beach and it gets washed away by the tides, but remember that the tides are crucial to so many animals and so many people. In conclusion, tides are really cool.